projects. In this video, we are going to explain about the project titled Blood Glucose Level Prediction, Advanced Deep Ensemble Learning Approach. Introduction. The primary objective of this project is to predict a person's blood glucose levels with high precision. Given the critical role of blood glucose in managing conditions like diabetes, having a dependable prediction tool is essential for helping individuals maintain their health effectively. The need of this project stems from the vital requirement for accurate blood glucose predictions in diabetes management. Individuals with diabetes must make informed decisions regarding their diet, medication, and lifestyle. Accurate predictions enable them to do so, resulting in better health outcomes and an improved quality of life. To achieve this goal, the project utilizes advanced techniques such as voting classifier, voting regression, and convolutional neural network (CNNs). These sophisticated methods work together to provide highly accurate blood glucose predictions. This tool is not only beneficial for individuals managing diabetes but also for healthcare providers and researchers. It contributes to better diabetes management and enhances our understanding of how blood glucose levels change over time, ultimately improving the overall care and well-being of individuals with diabetes. Objective. The main objective of this project is to achieve precise predictions of blood glucose levels. This is critically important for individuals with diabetes as it enables them to make informed decisions about their health. Having reliable predictions help them manage the condition effectively and make necessary adjustments. To fulfill this goal, the project utilizes a variety of advanced algorithms, including linear regression, static regression, lasso, ridge, voting regression, voting classifier, CNN, convolutional neural network, VLSTM, variation in long short-term memory, and BiLSTM, bidirectional long short-term memory. These algorithms work collaboratively to improve the accuracy of blood glucose predictions. By combining their strengths, the project enhances its ability to provide reliable and precise results. The ultimate aim of the project is to create a dependable tool that empowers individuals to take charge of their health. It not only benefits those with diabetes by enabling them to make proactive health decisions but also assists healthcare providers in making well-informed treatment choices. Additionally, the project contributes to advancing our overall understanding of blood glucose dynamics. This in turn enhances the overall quality of life for individuals living with diabetes, making it a valuable endeavor for both patients and the medical community. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of project. To implement this project, we have designed the following modules. The first module is importing the packages. In this module, the project begins by importing necessary software packages and libraries. These packages provide the tools and functions required for various data analysis and machine learning tasks. The various packages which we have used are NumPy, used for efficient numerical operations and array handling. Pandas for data manipulation and analysis, particularly for tabular data. TensorFlow, a deep learning framework used for building and training neural network models. Matplotlib, utilized for creating data visualization and plots. Seaborn provides aesthetically pleasing statistical data visualization. Scikit-learn offers tools for machine learning model development, evaluation, and pre-processing. Transformers, used for natural language processing (NLP) tasks, including tokenization and transfer learning with pre-trained models like BERT. Exploring the dataset. Dataset 2019 cholesterol.csv. This module involves loading and examining the dataset named Dataset 2119 cholesterol.csv. Exploratory data analysis (EDA) is performed to understand the dataset structure, content, and characteristics. This step is crucial to gain insights into the data before further processing. Data processing and cleaning. Data pre-processing and cleaning are essential steps in preparing the dataset for modeling. This module involves tasks such as handling missing values, removing outliers, encoding categorical variables, and scaling or normalizing numerical features. The goal is to ensure that the data is in a suitable format for machine learning algorithms. Splitting the data to train and test. After data preparation, the dataset is divided into two subsets, the training set and the testing set. The training set is used to train machine learning models, while the testing set is reserved for evaluating model performance. This split allows for assessing how well the models generalize to unseen data, helping to avoid overfitting. Building the model, in which we have different algorithms. The algorithms which we have used are linear regression. Linear regression is used to establish a linear relationship between input features and blood glucose levels, providing a baseline model for comparison. Baseline regression. Baseline regression likely refers to a simple regression model with minimal complexity, serving as a reference point to evaluate the performance of more advanced models. Multivariate regression. Multivariate regression extends linear regression to multiple input features, capturing complex relationships between these features and blood glucose levels. Stacking regression. Stacking regression combines predictions from multi-base models to create an ensemble, enhancing prediction accuracy by leveraging diverse model strength. Lasso. Lasso regression is used to perform feature selection, helping identify the most relevant input features for predicting blood glucose levels and reducing overfitting. Ridge. Ridge regression mitigates multicollinearity in the dataset, improving the stability and robustness of the predictive models. Voting regression. Voting regression combines the predictions of multiple regression models, allowing for a more robust and accurate blood glucose prediction by aggregating different model outputs. Voting classifier. Voting classifier combines the predictions of multiple classification models, possibly for tasks related to diabetes classification or risk assessment. CNN, convolutional neural networks. CNNs are used for extracting spatial patterns and features from input data, which can be valuable when the dataset includes sequential or image-based information related to blood glucose levels. VLSTM, variational long short-term memory. VLSTM is a variant of recurrent neural network LSTM that captures temporal dependencies in the data. Suitable for modeling time series patterns in blood glucose data. BiLSTM, bidirectional long short-term memory. BiLSTM extends LSTM by considering both past and future data points, enhancing the ability to capture complex temporal patterns, which is crucial for blood glucose level prediction. Training the model. In this module, machine learning models are trained using the prepared dataset. The models learn patterns and relationships between input features and blood glucose levels during this process. Building the model with voting classifier, since it gives better accuracy comparing with other models. The voting classifier is chosen as the primary model for blood glucose prediction because it has demonstrated superior accuracy compared to other models. It combines the predictions of multiple underlying models benefiting from their diverse strengths. Flask framework with SQLite for sign up and sign in. Flask is used to create a web application that allows users to sign up and sign in. SQLite serves as a database to store user account information securely. This functionality ensures that the users can interact with the system securely and have personalized experiences. User gives input as feature values. User input their feature values related to blood glucose prediction such as diet, exercise, and medical history. This step allows for personalized predictions based on individual health data. The given input is pre-processed for prediction. The user's input is pre-processed to ensure it aligns with the format and features used during model training. This step prepares the input for feeding into the predictive model. Trained model is used for prediction. The pre-processed user input is passed to the trained voting classifier model. The model makes predictions based on the user's data, providing an estimate of the blood glucose levels. Final outcome is displayed through front end. The predicted blood glucose level is presented to the user through the web application's front end. Users can assess their predictions, which can assist them in managing their health effectively. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Open the Anaconda prompt. Use the cd command followed by a space and then paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. Here I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is this, and port, which is this. Now copy the local link. I'm copying the link and paste this link into any web browser. I usually prefer Google Chrome. And hit enter. The home page of the project is displayed in the browser. This is the front end built using Flask framework. Now click on sign up button. If we are a new user, we need to register first, but I have already registered, so click on sign in button. This is the login form. Here we need to enter the username and the password which we have used. So here I am entering the username and the password. Now click on login. This is the home page of the project. Here we need to enter these parameters to predict the blood glucose level, and then based on the blood glucose level we will predict whether the patient is having diabetes or not. So I am entering these details. Here I have entered all these parameters, that is the number of pregnancies, blood pressure, skin thickness, insulin, body mass index, BMI, diabetes pedigree function and the age. After entering all these details, click on submit. So here we can see we got the outcome, that is the predicted blood glucose level is 148 milligram per deciliter. And here we can see based on the given input and blood glucose level, the patient is predicted with diabetes. So we can see that the patient is having diabetes. Now let us upload some more details of the other patient and check whether that patient is having diabetes or not. So I'm entering the details of the other patient. Here I have entered all the details, that is pregnancies, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function and the age. Now click on submit. So here we can see the predicted blood glucose level is 85 milligram per deciliter, and based on the given input and blood glucose level, the patient is predicted with no diabetes. So in this way, by entering the details, we can get the blood glucose level, and based on the blood glucose level we can predict whether the patient is having diabetes or not. The conclusion of the project is this project has achieved an impressively high level of accuracy in predicting blood glucose levels. It employs advanced deep learning techniques that enable it to make predictions very close to the actual values. This accuracy is a significant achievement as it ensures that individuals can rely on the predictions for critical health decisions. The project offers a user-friendly interface where individuals can input their health-related data such as diet, exercise, and medical history. This interface provides a convenient and accessible way for individuals to manage their diabetes. It offers valuable assistance by using advanced algorithms to process this data and provide predictions, enabling users to make informed choices about their health. Beyond individual health management, the project has broader implications. It contributes to enhancing the quality of life for individuals living with diabetes by providing them with a reliable tool for health management. Simultaneously, it advances our understanding of blood glucose dynamics, which benefits both patients and healthcare professionals. This increased knowledge can lead to better treatment strategies and improved patient outcomes.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.